Hello, everybody, and welcome to the BrainCo Education STEM Education Webinar Series. My name is Andrew Bannish. I'm going to start my camera right here so I can see more and more people come into our room. So I'm just going to get started right here. Really excited to be able to talk to you all today. I know we've all been cooped inside rooms for almost over a month now. I know in Boston it's been probably about 7 weeks. And it's nice to get a little bit of extra information while we're making the best of what we can in the current moment. So today, we have a couple of different guests who are going to be able to talk to us about block-based programming. If you're new to STEM, if you want to integrate different programming exercises within your classrooms or your schools, we hope that today can be a good introduction to all these things. So I will go ahead and get started here. So just like I mentioned, if you've heard of block-based program but haven't put it to use yet, or maybe you're still feeling it out, we brought in a guest today who'll be able to talk you through some of these essentials of putting this together. And today we're actually going to do 3 different sessions on this. So you can see Wednesday, April 15th here. We're going to introduce it at 1 o'clock. At 2 p.m., you're going to be able to preview one of our lessons where we can create an interactive game with block-based programming. It's a lot easier than you can imagine. And at 3 o'clock, we're going to use that knowledge that we gained from today's first 2 webinars to then apply it to program an actual moving hand. And so by the end of the day today, if you follow along with us, you'll be able to program this robotic hand. So it'll be a lot of fun. And if you want to stick with us, you like these presentations, on Thursday, we'll be previewing our biotech curriculum using that same robotic hand. And on Friday, I'll be able to give everybody the full picture of what this product can do and some of the creative challenges we've put around it. So any of those things you're interested in, take a look at the link below and feel free to register for whatever you'd like to do. So our whole curriculum series using that STEM hand goes from mechanical engineering all the way through biotech, engineering, design, programming. I can see this video gets in the way, all the way up to a creative challenge where you can take all the things that you've learned through these curriculums and then actually create a creation and submit it to MIT and Harvard alumni who will then grade it for you. So it's a capstone project. We've put this around a semester-long module that you can put within a class or an after-school activity. There's all kinds of different things you can do with it too. But today is just an example of how we can get that moving with programming. All right, so I'm very happy to bring on Judy Wang, who is one of our curriculum developers. And as you can see in the instruction here, she's a STEM education specialist and she's worked in places like San Diego's High Tech High. There's actually a documentary that came out in 2015. I forget the exact name of it, but they profiled High Tech High and how all the amazing things that happen there. Judy's had some great experience there. The Francis Parker School, and she's actually been curriculum developer for Make Block Education. So she has her master's degree in digital age learning and education technology from the Johns Hopkins School of Education. And she's been actually absolutely awesome working with us. And she'll be able to take it from here and lead us through our introduction to block-based programming. So feel free to give a better introduction than I could possibly do, Judy. And I'll stop sharing my screen and hand it over to you.
All right. Thank you, Andrew. Let's see. Let me share my screen. Oops. Hi, everyone. So as Andrew introduced, my name is Judy Wang, and I'm very excited to be here today because one of my passions is really introducing coding at all levels. So let's just dive right in and really talk about what block-based programming is. So when teachers or students first think of coding, they usually think of the text form. But really block-based programming has made that so much more accessible because you could think of it as presets. So it's easier to learn. It promotes computational thinking. And yes, it can be more limited than the actual text version because you can't personalize it as much, but because the presets are there and because it's so accessible, it's really, really easy for students to play around with and get really creative. So what you'll see today is the animation portion, like you see here, sprites, the background, and the potential it has for the hardware control. This programming language really is easy for students to learn and can really lead to cool projects. So here's the basic interface. The characters that you're going to control are called sprites. The background you see is the background, and the devices that you'll eventually connect is the devices portion there. The first thing that struck out to me when I used this interface was that everything was color coded. So that's awesome. It really makes it easy for teachers when they're just glancing at students' screens to see if they're on task or not, just to look for those colors, and for students to almost unconsciously go to each color as they become more familiar with it. So I'm a really big fan of this interface. So here are all the concept of blocks, and before you feel too overwhelmed, these are the block types that students would be introduced to in our curriculum that would help them become creative and be able to participate in the final project, which is to create an interactive game, plus the hardware portion. So students will be learning concepts like sequence, which is the order of things and how to actually get the sprite to start. And you can see blocks like when the flag is clicked, when space key is pressed, so on and so forth, loops, things that keep on repeating. And like I said, because these are presets, it's really easy for students to learn. And you can actually change the number here to go on forever, or to go on for 100, 5, 1, what have you. And this is where it becomes more fun. You can do conditionals, and if blank, then blank. So you can actually put something called operators there, which is like math formulas, like blank or blank, then do blank. It'll come more clear when I actually show you guys how it's used. And then there's the variable portion, which is basically a little scoreboard you can create. And my favorite, the movement, where you can really stack on a lot of different things to get the sprite to move about every which way. So all this is on the MBlock interface, and MBlock is a free block-based programming platform. And for those of your students, or for those of you who've actually worked with Scratch or Scratch Junior, they'll be very familiar with this because the blocks are basically identical. It has really easy hardware compatibility, and because it's so similar to Scratch, you can actually download the Scratch code into MBlock itself. So there's a lot of free curriculum and support available, whether it's different teacher blogs, YouTube, what have you. So if you guys are ready, let's go to the examples. So here is a scene that we have. Because everyone's so cooped up, I thought it would be nice to choose a background that's outdoors. And we have a panda sprite and a beaver sprite. So what you notice first off is that each of the sprite you have to code on its own. So for example, here's a sequence block. When the flag is clicked, the panda is going to say, coding is fun for 2 seconds. So let's see if that works. So that's something that's really simple. To make it a little more interesting, you can make both of these sprites move at the same time with the same sequence or the same prompt. So when space is pressed, the panda is actually going to switch to a bear. And for the beaver, when the space is pressed, it's going to move away and think, oh no. So let's see if that works. There you go. And what I really appreciate about MBlock interface is that when the code is being worked, it actually, like you saw, it highlights it. So to reset this, I'm going to click on the sprite and I'm going to click A, which will bring the beaver back to place. To make things a little more interesting, I thought it would be fun to show you the game aspects of it. So here is the conditional block that I talked about before. If blank, then blank. So I want, when the B key is pressed, if, so here's the operators. If the beaver is going to be touching the edge, oops, or if it touches the panda, and I put that in there, just like building Legos, then I want, oops, I want the score to change by 1. So, oh, and most importantly, when B key is pressed, the beaver, I've programmed it to go to a random position. You can actually have a lot of options, but because I wanted to make it into a game, I'm going to choose random position. So let's see, because he touched the edge, you can see the score changing to 2. You can see the score changing to 3, so on and so forth. What this will look like at a more advanced level is something like this, where you can actually program the monkey to catch the apples. That was a little preview for what's to come at the second one. Okay. So if you guys have any questions, please feel free to write them in the Q&A section, or you can share out loud and I'll be happy to show you guys more of what the interface can do.
Yeah, so how about while we're looking at this whole section here, Judy, could you show us a couple of other ways that we could implement other like movements into this picture that you put in?
Yeah, so we can even, let's see. So let's work with the panda. So you have so many options here to press many different things. So let's see, if I press the up arrow, then I want the panda to change X by blank. And what's important to remember is the X and Y axis, so your students will have to have that understanding. And then actually 10 here is not that significant, so you can even change it to maybe 25. So when I press the up arrow, it moves as so. We can even make it play silly sounds. And actually, students have the opportunity to record their own sounds. So I've had students basically present a monologue, you can say, with a sprite. And it becomes really interesting, this platform, because it's a really creative way to showcase students' knowledge, not just about coding, but for different projects like a book report or a character that they would want to see, because, or like a historical figure, because you can actually upload your own sprites here with this upload, and you can paint on them to make it to personalize it. And you can change the backgrounds. Here are all the different options. And like, as always, you can upload your own. And what's really cool is that you can actually program the backdrops to change. So if I wanted to, let's say, go into the city, I can do that. And you can program the background to change basically when the space key is pressed, so on and so forth. What I would like to do is to show you guys more about how the operator can work. So these conditionals become way more interesting when you think about the operator portion. And this is basically like a math puzzle you can do with your students because you have things like blank and blank. If blank and blank, then blank, or if blank or blank, then blank. Or so these are something that's really fun to do. So if the panda was to touch, oops. If the panda was to touch a certain color, and you could actually change the color itself. It would have to match the background for it to work. You can actually take that. Take this color. Put it in. Then I would want it to go to, basically, I would want it to fly. And so this X, like I said, you have to really understand the X and Y axis here. But an easy way to figure that out is you can just place the sprite into wherever you want it to go. And it says the X and Y axis points there. So you can just copy it in and bring it back. Else I would want it to so let's see. And one of the things that your students will learn is that, of course, code cannot start unless there is the event block, which is under the concept of sequencing. So if, let's say, K. Yep. So because it was touching the green, or you can even make it touch that teal color there, it's going to go to a certain place in the X and Y axis. There you go. Are there any specific blocks that you guys would like to see? As a teacher, like I said, because it is color-coded, it's really easy for you to just glance at students' screens and to see if they're on the right track. And what's really awesome about MBlock is that you can access students' files that they save. And you just run through their code to see if they're on the right track or not. And because all the presets are there, it's easy to help students understand where they went wrong and what they can do to make their code work. And I found that students get really excited because there's so much personalization that comes with MBlock itself. And you can even add background sounds as well.
Hey, Judy. Gonna jump in and ask some questions here. So I have one question from Jenna, who says, would this work with 5th grade students?
Yes. So when I worked at High Tech High, I worked with 5th graders for them to design their own game, and we pretended that they were on Mars because we're learning about space. And they had a really great time learning and personalizing their game. It takes a little bit of concentration for them to really understand the operators, the blank and blank, or blank or blank, not blank. But it's very doable for them. So yeah, it's not too hard. And if they have been playing around with something like Scratch Junior, which is just a more constrained version of this, then the interface would be much more familiar. Yeah.
Great. So actually, Jenna, I'm gonna allow you to talk if you'd like to ask any additional follow-up questions, and if not, that's totally fine. You can just keep yourself on mute. And while we're thinking about that, yeah, Judy, could you give us a couple more examples of ways that you've implemented this into different classrooms or students?
Yeah, so another creative way that I think coding can really help is learning about different, basically different math problems. So let me share my screen again. So you have things like these operators here. Oops. Plus, minus, multiplication, and division. And you even have these math operators, greater than, less than, or equal to. So what's been really fun is for students to solve math problems using these. So for example, if the variable is going to be a certain number, then the sprite will do blank. If the variable is going to be greater than 100, the sprite will do a certain action. If it's equal, it'll do a certain action. If it's less than, it'll do a certain action. So it's really fun for students to solve math problems through their computer through coding. For example, let's see. So we can do things like if the score is oops. Then we can, let's see, make the background sound pop. And in order for that to happen, we would have to, let's see. Oops. Score to 5. But I forgot to put the event block, so. Yeah, and like I said, you have the option to record your own sound there. Any other questions?
That's great. And yeah, while we're getting some questions coming here, I just wanted to remind everybody that we do have additional webinars today at 2 o'clock and 3 o'clock, where we'll be taking these fundamentals that Judy just brought us through to then create an interactive game that's really fun to operate in the classroom with a group of students and get them moving with programming. And then at 3 o'clock, we'll be discussing more about how they can use those lessons learned to actually implement hardware into their games and their other coding exercises. So yeah, this can all be a really fun way to bring this all together into a classroom. I think beyond just the things that we've seen on the screen today, Judy, like a question that we're getting here is what ways have you implemented programming education over a semester, like with this kind of programming language?
Yeah, so coding, especially on NBlock, it's easy to integrate different facets of learning into it. So for example, if the theme is games, we would do readings about games in different cultures. We would do short writing pieces. Like I said, we will do some logic challenges with coding. And because it's easy to turn on, it's basically on your Chromebook. There's no complicated setup time. Students just log into their saved files. It's easy for me to keep track of what students are doing, who's having trouble with what concept. So over the semester, it's easy to work in bits and pieces to the final project, like an interactive game.
Great. Okay, so it looks like that one's all set. Let me pull up the next question here. Let's see here. We have another question. Judy, have you done anything with MBlock regarding distance learning? Oh, I imagine that's like a big topic right now.
Yeah, so because MBlock, there's so many tutorials, it's easy to share your screen and basically show what the concept looks like in real time. And the great thing about technology is that whether you're in the same classroom or not, there's screen functions, so you can really check in with the students individually to make sure they're on the right track and just talk them through it. So I think the advantage of MBlock here is that there's no disadvantage that you're not in the same classroom with them. And you always have a camera, so you'll be able to see if their hand is working or not. Yeah.
Awesome. So we have one more question. And just want to remind everybody out there, if you have any other questions, feel free to submit them in here so we can make sure there's time for it. So the last question we have here is, Judy, how do you manage the transition from block-based programming to text programming?
So that's a great question. Because students work on their skill of computational thinking, as soon as they recognize that there is a certain pattern, it's easier for them to basically translate that block into a certain text and just code it line by line. So there are different types of coding, and it doesn't translate directly, but the skills, the critical thinking skills and the computational thinking skills that the students are working with, where they put a piece into another piece, or they make sure that it follows a certain sequence and certain conditions, it really primes them for success when it comes to the text-based coding. And yeah, and I think that's what they'll interact with in AP Comp Sci and at the high school and at the university level. So yeah, this is just, it just lays a great foundation.
Great. Yeah, so that's all of our questions here. I'll give everybody another 20-second window if they want to ask anything else to Judy. But allow me to say, Judy, thanks for putting all this together. Just like I mentioned, we'll have another webinar at 2 o'clock if you want to take these fundamentals and put them into an actual game that you could work on with students. But I wanted to thank you again. And yeah, if anybody else wants to preview anything else that we're doing this week, feel free to visit our website that I just put into the chat. We do have a chat bot there where you can get in touch with any of our people here remotely if you have any additional questions. Not to mention, you could take a look at some of our other upcoming webinars. Yeah, so Judy, are there any other concluding thoughts that you have on block-based programming for people who are new to it?
Yes, that it's easy for teachers to learn, and it's really fun. And the block-based programming is very forgiving because you can really learn through trial and error, even if you don't have the time to sit down and listen to an hour of tutorials. So it's very doable, and we're excited for you guys to try it in your classrooms.
Great. Well, that's the perfect way to wrap it up. Well, thank you everybody for participating in this webinar. Feel free to chime in again at 2 o'clock, and hope you learned something new and have something new that you can implement in your classrooms. So thanks a lot, and we'll see you at 2 o'clock.
Bye.
Goodbye, everybody.